Hello friends, this is the ninth lecture on applications of derivative. I will explain 10 examples. Okay, and the topic is derivative at a rate measure. Now let us start. These are the important formulas. That is the equation of the tangents and the normal. And this is the figure. Curve y is equals to f of x, tangent and the normal. Now in this lecture, I will explain 10 examples on derivative as a rate measure. Now the first example, a water is being poured into an open cylindrical can of radius 5 feet at the rate of 15 cubic feet per minute. The depth of the water in the can is increasing at the rate of, these are the options. Let V be the volume and H be the depth of water at time t. V is equals to pi r square into H, R is equals to 5. V is equals to, if we substitute R is equals to 5, then V is equals to 25 pi H. dV by dt is equals to 25 pi into dH upon dt. We know dV by dt is equals to 15 cubic feet per minute. Then if we substitute it, then you will have 15 is equals to 25 pi dH upon dt. And hence dH upon dt is equals to 3 upon 5 pi feet per minute. Therefore, the depth of the water is increasing at the rate of 3 upon 5 pi feet per minute. Okay. And hence option C is correct here. Next example. A water is running into an inverted cone at the rate of 270 cubic centimeter per minute. The radius of cone is equals to the depth of water in it. When the water is 18 centimeter deep, the rate at which water level is rising is, okay, all these A, B, C, D are, these are the options. Now see the solution. Here R is equals to H, okay, and hence the volume of the cone is equals to 1 by 3 pi r square into H. Substitute R is equals to H, therefore pi by 3 H square into H, and hence volume of the cone is equals to pi by 3 into H cube. Differentiate this with respect to t, therefore dv by dt is equals to pi by 3 3h square into dh upon dt, and hence 3 get cancelled. Then you will have pi into h square into dh upon dt. If here h is equals to 18 centimeter, substitute dv by dt is a 270 centimeter cube per minute. If we substitute it, that is, then we'll have, that is a 270 is equals to pi 18 square into dh upon dt, and hence dh by dt is equals to 5 upon 6 pi centimeter per minute, and hence option A is correct here. Next example. A tank is in the form of inverted cone having height 8 meters and base radius 2 meters. Water is flowing into the tank at the rate of 1 by 8 cubic meter per minute. The rate at which the water level is rising when the water is 2.5 meter deep is, these are the options. And here let h be the height, r be the radius. Okay, the radius of the water at any time t. Now here we have r upon h is equals to 2 by 8, that is equals to, therefore r is equals to h by 4. The volume of the cone V is equals to 1 by 3 pi r square into h is equals to pi by 3 into h by 4 bracket square. This is the value of r, okay, into h. Therefore V is equals to pi upon 48 into h cube. Okay, and therefore if we differentiate this with respect to t, then we will have dv by dt is equals to pi upon 16 into the derivative of h square is a 3h square, that is a 3 upon 48. Then you will have pi upon 16 here into h square into dh upon dt after simplification, when h is equals to 2.5 and dv by dt is equals to 1 by 8. After substituting, 1 by 8 is equals to pi upon 16 into 2.5 bracket square into dh by dt, and hence dh upon dt is equals to 8 upon 25 pi meters per minute. And therefore the water level is rising at the rate of 8 upon 25 pi meters per minute. And hence option B is a correct here. Next example. An aeroplane at an altitude of 960 meters flying horizontally at 720 km per hour passes directly over an observer. The rate at which it is approaching the observer when it is 1600 meters directly away from him is. Okay, these are the options. We want to find out the it what is the rate at which it approaches to the observer. Now here, see this the figure, height of the plane, y is the distance of the plane from the observer. Now from the figure, y square is equals to x square plus 960 bracket square. If y is equals to 1600, therefore x square is equals to 1600 bracket square minus 960 bracket square, and after simplification we'll have 1000, x is equals to 1280. Now differentiate this with respect to t. We want to find out dy by dt. Therefore derivative of y square is a 2y into dy by dt is equals to 2x into dx upon dt, and after simplification you will have dy by dt is equals to x upon y into dx upon dt. The value of x is 1280 upon 1600 into 720, and after simplification the answer is 576 km per hour, and this is the rate at which the aeroplane is approaching to the observer at the rate of 576 km per hour. Okay, and hence option A is a correct here. Next example. A ladder 10 meters long is leaning against vertical wall. If the bottom of the ladder is pulled horizontally away from the wall at the rate of 1.2 meter per second, then the rate at which the top of the ladder is sliding down the wall when the bottom is 6 meters from the wall. We want to find out dy by dt here. Okay, these are the options. Now here the solution. See this the figure. AC is the ladder. Okay, and x is equals to here 6. The length of the ladder is 10. We find out the value of the y by the Pythagoras. Here x square plus y square is equals to AC square. 6 square plus y square is equals to 100. Okay, therefore y square is equals to 64, y is equals to 8. X square plus y square is equals to 100. Differentiate this with respect to t. 2x into dx upon dt plus 2y into dy by dt is equals to 0. Therefore dy by dt is equals to minus x upon y. We want to find out the rate at which it is sliding. Okay, therefore dy by dt is equals to minus 6 upon 8 into 1.2, and after simplification you will have dy by dt is equals to minus 0.9, and hence option C is the correct here. Option C is here correct. Now the next example. A rod AB 10 meters long moves with ends A and B on two perpendicular lines OX and OY respectively. Same problem. Okay. If A is 6 meters away from O and moving away at the rate of 2 meters per second, then the rate at which B is moving is. These are the options. Now see this here. This is the figure, x-axis, y-axis. Okay. Here AB is the rod. Let the end A be x meters from O, and end B is a y meters from O at any time t. X square plus y square is equals to 100. Differentiate this with respect to t. Therefore 2x into dx, 2x into dx upon dt plus 2y into dy by dt is equals to 0. Therefore, dy by dt is equals to minus x upon y into dx upon dt. Now, when x is equals to 6, then y square is equals to 100 minus 36. After substituting, you will have y is equals to 8. Substitute the value of x and y in this equation. Therefore, dy by dt is equals to minus 6 upon 8 into 2, and after simplification dy by dt is equals to minus 1.5, and hence the end B is moving towards O. This here is a O at the rate of 1.5 meters per second. Okay. Now the next example. A man of height 1.5 meters walks towards a lamppost of height 4.5 meters at the rate of 3 by 4 meter per second. The rate at which the tip of the shadow is moving is, okay, these are the options. Now see this here, the figure we want to find out. The rate at which tip of the shadow is moving means we want to find out dx upon dt plus dy by dt. Okay, let x be the distance of the person mn from the lamp post AB at any time. Okay, and y be the length of his shadow. Okay, now from this figure, these two triangles are similar. That is a triangle ABC and MNC. Therefore, 4.5 upon x plus y is equals to 1.5 upon y. After substituting these values and simplification, you will have 3 upon x plus y is equals to 1 upon y. And after simplification, 3y is equals to x plus y. Therefore, 2y is equals to x. Okay. And therefore, 2 into dy by dt is equals to dx upon dt. And hence, dy by dt is equals to 1 upon 2 into dx upon dt. 1 by 2, we know the value of dx by dt, which is 3 by 4. Okay. And 3 by 4 into 1 upon 2 is equals to 3 by 8. And hence, the required answer, that is a dx upon dt is plus dy by dt is equals to 3 by 4 plus 3 by 8. After simplification, you will have it is a 9 by 8, and hence option C is a correct. Option C हा या ठिकाणी कसा आहे तर तो करेक्ट आहे. Next example. A man of height 180 centimeter is moving away from a lamp post at the rate of 1.2 meters per second. If the height of the lamp post is 4.5 meters, then the rate at which his shadow is lengthening is. Okay, these are the options. Now see this here. LL1 is the lamp post, PP1 is the man, his shadow is Y. Okay, distance of the man from the lamp post is X. Let X be the distance of the person PP1 from the S lamppost LL1 at any time T, and Y be the length of his shadow. And as these two triangles are again similar, that is a triangle LL1S and PP1S. Therefore, 4.5 upon x plus y is equals to 1.8 upon y. And after simplification, you will have 5 upon x plus y is equals to 2 upon y. And therefore, 5y is equals to 2x plus 2y. And after simplification, you will have here, that is a 3y is equals to 2x. Therefore, y is equals to 2 by 3 into x. Differentiate this with respect to t. dy by dt is equals to 2 by 3 into dx upon dt. Okay, therefore dy by dt is equals to 2 by 3 into the value of dx by dt, which is 1.2, that is equals to 0.8 meter per second. Okay, and hence the shadow is lengthening at the rate of 0.8 meter per second. and hence option B is a correct here. Okay, next example. If the perimeter and the area of a square change at the same rate, then the side of the square is. Okay, these are the options. Now the solution. Let x be the side, p and a be the perimeter and the area of the square. A is equals to x square area, p is equals to 4 into x. Differentiate this with respect to t. dA by dt is equals to 2x into dx upon dt. dp by dt is equals to 4 into dx by dt. Therefore, as these two rates are equal, therefore 2x into dx by dt is equals to 4 into dx by dt. Okay, dx by dt get cancelled on both sides. Therefore, 2x is equals to 4, x is equals to 4 by 2, and hence x is equals to 2. Okay, and hence option A is a correct here. Next example. If the circumference of a circle changes at the rate of 0.2 centimeter per second, then the rate at which its area is changing when its radius is 8 centimeter is. Okay, now let R be the radius, C be the circumference, and A be the area of the circle. C is equals to 2 pi r, A is equals to pi r square. Now express this area in terms of the circumference. Okay, now what is the value of R? R is equals to C upon 2 pi, therefore pi into C upon 2 pi bracket square, and hence you will have here C square upon 4 pi after simplification. Differentiate this with respect to t. dA by dt is equals to 1 upon 4 pi. Derivative of c square is a 2c into dc by dt. Okay, and substitute the value of again c, which is 2 pi r. Okay, therefore 1 upon 2 pi into 2 pi r into dc by dt. Okay, and here after the simplification you will have 8 into the value of dc by dt, the rate at which the circumference changes is 0.2, that is 8 into 0.2 is equals to 1.6 centimeter square per second. Okay, and hence option C is a correct here. And in this way we have completed all the 10 examples which depends on derivative as a rate measure. Now we'll see in the next video. Till then, goodbye.